Alright guys, here we go. Last video of the year. Talking about multiplying polynomials. A polynomial, poly means many, so it is an expression with multiple terms or many terms. They are only separated by addition or subtraction, not multiplication, not division. A monomial is an expression with one term, like x or 3. Or even 3x or negative 2x squared. None of those involve addition or subtraction, so it is just a monomial. Each of those is one term. A binomial, bi means two, so it must be an expression with two terms. You know, most linear things are binomials, like 2x plus 3. We could have binomial quadratics, or, something that looks like this. All those are binomials. It's two terms separated by an addition sign. Following the sort of pattern, tri means 3, so a trinomial is an expression with 3 terms. And most quadratics are trinomials. They have 3 terms. And it doesn't matter if every sign is addition or if every sign is subtraction. It does not matter if it's a mix, as long as it has 3 terms separated by addition or subtraction. We know how to multiply monomials. We just never called it that. Some of it involves our exponent rules, and some of it involves the distributive property. When I have a monomial times a monomial, so one term, use your exponent rules. I'm going to leave the 1 and 2 for you to do on your own. We'll do 3 together since it's a little more involved. We're just going to multiply our coefficients together, our like variables together, so x squared and x to the 9th, y to the 5th times y. Remember, y is the same as y to the 1st. When there's no exponent, the exponent is a 1. And we're just multiplying. So, whoa, no one's going to see that, yellow. 2 times 6, 12. When I multiply like bases, I'm going to add my exponents, so x to the 11th, y to the 6th. This is a review from last unit. You guys know how to do this. Same with multiplying a monomial times a binomial. So this is one term times 2 terms, monomial times binomial. Just distribute. So I'm going to do number 5. You're just going to distribute. So I'm going to do x squared times 4x squared plus, because I got to bring down this plus sign, x squared times, oops, that's a cubed, x squared times 3. And just multiply those terms. So x squared times 4x squared is 4x to the 4th and 3x squared. And that's your answer. We know how to do this. This is not new to us. We've been doing this all year. So you can pause the video now and do 1, 2, 4, and 6, or you can wait till the end of the video and go back and do them later. But it's just practice of distributing one term to a binomial or just a monomial times a monomial. And know your vocab. So monomial, oops, I can't spell, N-O-M-I-A-L times monomial. And down here, it is a monomial times a binomial. We got to talk about multiplying 2 binomials. This is something that you are not used to. Feel free, pause the video and do adding and subtracting. I'm going to do them real quick. Here, when I add these, I get 2x squared plus 5. I'm just combining my like terms. And then down here, I need to make sure I distribute this negative to both terms. and combine my like terms, I end up with -1. Okay, so here I ended up with a binomial. Here in the second example, I ended up with a monomial. Adding and subtracting, we've done those all year as well. This is where we get into new stuff, multiplying binomials. However, it's really not new. We just distribute. Since it's a binomial times a binomial, we need to distribute more than one term, but nonetheless, still distributing. I know this says method 1 and method 2, but there's no such thing, so I'm going to do this and just, whoops, let me make that bigger. I'm just going to make this one big box. We're only doing one method because that's what's really important here, and I don't want you to watch a 20-minute video, so the less methods, the better. Plus, no one ever really uses the other method, so there's no point of showing it to you. So, I have my two binomials. I'm doing x plus 2 times x plus 3, right? And this is our example. Remember, if there's no sign in between, you can add a dot to show multiplication, but you really don't need it. All I'm doing is distributing, and I know I keep saying that a lot, but it's really important that you kind of drill that into your head. I'm not doing anything fancy, I'm just distributing. I just have to do it one extra time here. So, previously, I did my monomial times both things in my binomial. Down here, I have to do the first term in my binomial times both terms in my binomial. So I get x times x plus x times 3. And I also need to do my 2 times my x and my 2 times my 3 plus 2 times x plus 2 times 3. A lot of people like to call this double distributing because you're distributing twice. You're distributing the x and you're distributing the 2. When I multiply all of this out, x times x is x squared. I get 3x, 2x, 6. I'm not simplified all the way. I need to make sure I combine my like terms. I'll underline them. X squared plus 5x plus 6. And that's how you multiply binomials. All right, guys, so we're almost done. 2 more examples, but before I go into the other 2 examples, I just want to say that there is an acronym. It's known as FOIL, and I've written it out up here, and it just helps you remember the order that you multiply in. So first means you do your first term times your first term, and outer means you do your outermost terms, which is what I did in the green. So that's distributing the x. And then you do your innermost 2 terms and your 2 times your 3, your last terms. That's what I did in the purple. And this only works for a binomial times a binomial, so a lot of people don't like to talk about it because it's a very specific case. But if it helps you remember the order to multiply, then feel free to do it. Okay, so your last 2 examples. It's important that we show you different ways that binomials can be expressed. So here we have x plus 3 squared, and we need to remember that an exponent means 3, like for example, 3 squared means 3 times 3, or x squared means x times x. It's the base times itself however many times the exponent says. I don't need to write that out, you know that. So I encourage you to pause the video right now and try to think about what x plus 3 squared really is using the definition of exponent. So go ahead and try that out. If I'm using the definition of exponent, then I know it's my base times itself. And then I am just going to distribute the first times the first. So x times x, which is x squared. My x times the 3, which is my outer two terms, 3x. Innermost two terms, 3x. And my last term times my last term. I need a color, pink. 3 times 3, which is 9. Don't forget to combine like terms. X squared plus 6x plus 9. Now I'm sure a lot of you really just tried to distribute the exponent. Do not do that. Okay, so make a note. Do not distribute the exponent. So I'm sure a lot of you had this. This is a big fat no. Don't do it. You miss out on that middle term, which is really important. Last example. You can do it. Power through. Last example of the year in a video. We got this, guys. X plus 3 times a trinomial. Whoa, what am I writing? X squared plus 2x minus 4. Remember, I'm multiplying. I'm just distributing. Distribute. Oh, why is my pen not working? There we go. Distribute the x to each term in the trinomial. So I get x times x squared is x to the third. X times 2x is 2x squared. This might help if I use different colors, which is going to make the video a tad longer, but I'm trying to help you out here. So I'm going to have x times x squared, x to the third, x times 2x, which is 2x squared, and I have x times negative 4, which is negative 4x. I'm double distributing here, or triple distributing in this case. I'm got to multiply my 3 now by everything in the trinomial, so I've got 3x squared plus 6x plus 12. No, minus 12, negative 4. Negative 4 times 3 is negative 12. Combine like terms. Make sure to combine like terms. So I've got x squared and x squared is 5x squared. Your x to the third did not change. My x's become negative 4x plus 6x negative 2x, and my negative 12 also did not change. So my binomial times my trinomial became a polynomial with 4 terms, and all I did was distribute. Bottom line, just distribute.